Hello, it's Maddi, and I'm going to talk to you about the response of a first-order plus dead time system to a step change of height m. Here you have your transfer function for a first-order plus dead time system, your process gain, times your dead time function, which is e to the negative theta s, and that's all over tau s plus 1, and your step change input of height m in the Laplace domain is m over s. When you multiply those together to get your output function, this is what it's going to look like. This is very difficult to mess with in the time domain, so we're going to use the 1,1 pad A approximation to look at the dead time function, and that is e to the negative theta s equals 1 minus theta s over 2 all over 1 plus theta s over 2. And when you substitute that in, your output function is going to look like this. We're not going to worry about actually transforming this into the time domain. Instead, we are going to look at graphs of the response in the time domain. This is what a graph to a response of a step change of height m in a first order plus dead time system looks like. Here I have the dead time circled so you can see the lag between when the system starts responding and when the step change input is put into the system. We're going to talk about what different responses happen when you change model parameters a little bit. When you change your process gain, if you make it larger, then the system responds more. If you make it smaller, then the response of the system is smaller. If you have a larger time constant, then it takes the system a longer time to respond to the input. If you have a smaller time constant, then it takes the system less time to respond to the input. And if you have a larger dead time, then the lag time for the system to start responding to the input is much larger. And if you have a smaller dead time, then the lag time for the system to start responding to the input is smaller. All of these graphs came from this website. I found it very helpful, so if you want to use it too, go for it.